Okay, everybody, this is chapter 7, section 2, and now we're going to look at similarity of polygons. So remember, polygon is a term that just says, I have a many-sided figure. So that could be anywhere from a triangle up to something that maybe has 100 sides. Couple rules here that we need here at the top. So for definition of similar polygons, the corresponding angles are going to be congruent, which is pretty important for what we're doing. You have to know that angles that match an angle from one figure to another figure, they're in the same place. Okay, that's, remember, transversal rules, what corresponding meant. Same place, those angles should be congruent. Okay, the second rule that goes with that is that the corresponding sides are proportional. So that's kind of what we did last section. We looked at proportions and ratios, and we also called something as a ratio being a scale factor. So remember what that was. A proportion we learned was A over B, or a ratio, I'm sorry. Ratio is A over B, it's one fraction. And I can write that as a scale factor. So remember that I didn't really mention this, I think, last section, but the numerator becomes the first number followed by the denominator of the second number, okay? All right, so make sure you have those two things down. The angles are always going to be equal, and then we got the sides will be proportional to each other. So basically what you need to know here is the two figures are not going to be congruent to each other, but they're going to have a similarity, all right? In this one picture we have a pentagon and a second one that's a little bit smaller, but they're similar. So they're telling us that. That's one thing that we need to understand. They're saying they are similar, so they have a proportion. List all the pairs of the congruent angles, and then write the extended proportion for the ratios of corresponding sides. So I'm going to show you kind of a way to do this that you can, there's different ways to write this out. So I'm going to show you kind of the two different ways, and then whichever way you want to write it is fine. Okay. So let's start with the angles since they're congruent. Let's just do that. I'm going to start up here at the top. You can start wherever you want, but let's just do the same today. Angle J is going to be congruent to its corresponding angle. Okay, so I'm assuming that angle J and S are corresponding. All right. So they're congruent to each other, all right? And I'm just going to now go around the figure doing that, all right? So I'm going to go clockwise. So K and T. Angle K is congruent to angle T, okay? And typically you go left to right, okay? Unless you're given specific information, do it, like small to big or big to small, whichever. But typically, I'm going to start with the figure on the left-hand side and go into the one on the right. And like I said, you could have started anywhere. I could have started down here at M and gone around. Doesn't matter where I start. Okay. L is going to be congruent to angle U. Angle V, M is congruent to angle B. Angle W is congruent to angle N. Okay, so we hit all 5 angles, and the corresponding angles are congruent. Sorry about my writing today. Okay, now we want to write an extended proportion for the ratios of the corresponding sides. So this one's a little bit kind of funky. I'm going to do it 2 different ways so you can see it. And the first way I'm going to do is not technically an extended proportion, so hopefully you'll get that. And also what I want you to do is that this little squiggly stands for the word similar. Okay, so that's what that means. So when we talk about sides in this case, sides are going to be similar to each other, but they're not congruent. All right, so I'm going to take, once again, I'm going to start with, I always start with the figure on the left, and I go around, I can go counterclockwise if I want, doesn't matter. But you pick a place to start, and we start just going from there, but start with the left. So I'm going to start with JK. So side JK, which is a line segment, is going to be similar to, and ST is its corresponding side. Okay. And just go around now and hit every one that you can. So I got this one side KL is going to be similar to side TU. Okay. Keep on going. So LM is similar to UV. Sorry about that. And then MN is similar to VW. Okay, and then last one, NJ, similar to WS. Okay, so there's that. Okay, now what an extended one is a little bit different. This one to me just seems, I think, a little bit more understandable, even though it took a lot to write. Okay, and the other one actually takes a lot to write too. So I'm going to do that on a separate page, I think, and have just, you guys can write it into your notes where you can. So I'll do this on a separate page. So I'm going to take the sides that were congruent or similar. So JK was similar to ST, but I'm going to write them in a ratio form. Okay. So I'm taking the two sides that were similar and writing them like as a fraction or a ratio. And then I'm going to say, because they're proportional, the proportions are equal to, and I'm going to write the next set of sides. So KL was similar to TU, and that proportion is going to be equal to LM and UV, and that's going to be similar to MN and VW, which is then going to be similar to NJ and WS. Okay, now that's an extended proportion because proportions are equal. If you remember when we did our cross products, they were equal to each other. So proportions in extended proportion, they would be, you'd use the equal sign. Okay, and I'm putting similar sides over similar sides, and it was the, you know, the left, the one that was on the left was the bigger one, so I used those on top, and I used the one on the right, the smaller one, on the bottom, but the similar sides kind of stay together. Okay, so that's kind of how to write it. Again, you'll probably see that a few times. Just want to make sure you see it different ways, because we'll do it different ways as we go forward. Okay, all right. Let's see. I think I got everything on that last page. Let me double check this. If not, here we go. Okay, they're telling us, or they're asking us to decide if the figures are similar. Now, that means that the proportions have to all be the same as we go through. Okay, I can't really tell by the angles. I'm going to assume that they are going to be congruent, but there's nothing for me to be able to do that. So now I need to look at sides. So once again, I'm going to start with this one first and this one second, and I'm going to put it just in a ratio form and then reduce it. Now, by doing that, that will tell me all of them, all the rest of those ratios have to be the same for this to be equal or proportional. Okay, so I'll start with XY again. Start the left-hand side. I'll start on top. It's 6, and the other one is its corresponding side is 4. Can I reduce it? Yes, I can, to 3/2. So this is where you probably need to write a note to yourself. All the other ratios have to be 3/2. So I'm going to take corresponding sides and see if I all get 3/2. If I don't get that, then they're not going to be that the two figures are not proportional. Okay, so let's start with here. I'm going to go XW and QP. So that's 15 over 10. Okay, it's reducible. 5 goes into both the top and the bottom. I get 3 over 2. Okay, so that side's similar. Those two sides are similar because they have the same ratio as the first one that I did. But they all are going to have to do that. Okay, so I'm going to go here. I'm going to go 12 over 8. Okay, and that's reducible. 4 goes into both the top and the bottom, and I get 3 over 2 again. So right about now I'm going, hey, they're similar. I don't want to do the rest of the work, but all the sides need to have the same ratio. So I'm going to go with the last side, and I get 9 over 5. That's not reducible, so that's the ratio of those two sides. This one's not the same as those other 3, so that tells me that no, they are not similar. Okay, so I have to go all the way around and make sure that all of them have the same ratio, reduced as far as you can. That also would then tell me too that at least one of the angles is not, they're not congruent. The corresponding angles are not congruent. Okay, so that one takes a little bit of time. You got to go all the way around. Don't just start getting, oh, they look like it's going to be the same. They look like they're the same. You got to prove it. Okay. My little note sheet. Okay, for scale factor, I'll write this down for you. All lengths are proportional. So basically I have to do what I just did to prove this. All lengths are going to be proportional to their actual lengths. Okay. And remember, the scale factor is written in this way. So we get rid of the fractions basically and write it like that. So if you guys ever look at a map of something, you know, a map is not a true representation of like a city. So a city map is written or drawn proportionally to what the actual size of the city is. So somewhere on the map, they got to tell you, hey, here's the scale factor. So 1 inch on this map might actually equal 3 miles in real life. So you have to be given kind of a scale factor to understand what the dimensions are. Okay, so they're telling us here that they are similar polygons, so they want the scale factor. So you got a choice here. What do you want to do? So I could pick this one, and its corresponding side is this. Once again, I'm kind of working left to right, like you read a book. So it's going to be 15 to 12. I'm writing it as a scale factor. That's what they asked me to do. But scale factors are a fraction, basically. So you want to reduce these if you can. So if both 3 goes into both numbers, and my scale factor would be 5 to 4. Okay. Now let's kind of prove it. Let's play it then with the other 2 that they gave us. They gave us these 2 sides, which are corresponding. So that's 25 to 20. Okay, but that's reducible. 5 goes into both, and I got the same scale factor. So, you know, they told me already they're similar. I'm just proving that with what they gave me. Okay, but that's my answer was, what is the scale factor? It's 5 to 4. Okay, and now remember, you don't have to do this, but remember, you can turn that into a ratio. First number on top, second number as the denominator. Okay. Okay. All right, so these are ones, this is more of what we're going to be dealing with. We're going to get two different figures, and we're going to determine what value for the variable that they're giving us, what value would make them similar. Okay, so when I do these, there's a couple different ways to do this, and I'm kind of that corresponding type of, this is the way I set it up. So I'm going to always start, we're going to go left to right again. Okay, doesn't matter which side I start with, but I'll start with this one, and I'm going to set up we're going to set up our proportions. So we're going to use cross products. This side is proportional to Z. Okay, and since I started here, then I'm going to take another side from that same figure, put it on top. So the 10 and 15 came from the same figure, and the 15 is corresponding to the 6. Okay, so that's the way I set them up. I use corresponding sides to set them up. But if you guys, what some other people do, and what other books teach it maybe a different way sometimes, but using one of the rules we got from section 1, I can flip these two. I can switch them. So I can get 10 over 15 equals Z over 6. And there's a lot of people that use that way to set these up. But remember, by just switching those two, it's not going to change anything. I'm still going to have to do cross products. And either way I look at it, I'm still going to get 15Z. But this way, for me, I feel like I set it up correctly. I'm not going to screw something up. I set it up correctly more often, and I don't make a mistake right off the bat. Even before I start doing anything, I'm good to go. So I don't mind which way you set it up, but I just feel like the first way I showed you kind of gives you a better chance of being successful. Okay. So doing your cross products, 15 times Z is 15Z, 10 times 6 is 60. I'm going to go ahead and divide both sides by 15, and I'm going to get Z is equal to 4. Okay. So Z has to be 4 for those two figures to be similar. Okay. All right. So I'm going to go ahead and let you guys try the second one on your own. If you want to hit pause and do your work and then go on back, and I'm going to start doing the solution. So give it a shot and let's see if we agree. Okay. Okay. So you get that. I did my corresponding side one. If you did it the second way, that's cool. These two would be flipped. I'm not going to worry how you set it up. Just let's make sure we get the right answer, okay? And then by doing all my math, I get the missing side as being 4.2. Okay. So kind of be careful here too. You got to, sometimes you have to rotate these figures so that you get the same kind of angle at the way that you look at it. This side was the longest side, and it corresponds to the other longest side. So you got to make sure that you're helping yourself out that way. Okay. And let's use some common sense. If you look at 2.4 and you compare it to 5.1, it's a little bit less than half of its longer side. So did the value we get for X, is it a little bit less than half of 9? And it is. Okay. So I kind of use that to also kind of check my work, use some common sense. Okay. All right. So that was 7.2, I hope that, you know, that was kind of straightforward. It's just doing some math and setting it up. But the biggest thing is setting it up properly. So, you know, make sure you're doing that. And if you got any questions, make sure you get a hold of me, okay?